Hi, everyone. Welcome. Hi, everyone, and welcome to our weekly. All right, let's try that again. Okay. Hi.
Turn off the volume on your computer, your speakers. Turn off the volume on your speakers on your computer.
Let's try that again. Hi, everyone. Welcome to our weekly Committee on Education workshop. My name is Monica Moore, and I'm one of the workshop co-chairs. We are really excited to have William Delgado joining us today to tell us about his work. So William Delgado is a postdoctoral scholar at the Harris School of Public Policy here at University of Chicago. His current research studies teacher quality in K-12 and a field experiment intended to improve preschool children's early math skills. Delgado received his bachelor's and master's in economics from the Universidad de los Andes and his PhD and master's, Delgado received his bachelor's and master's in economics from the Universidad de los Andes and his PhD and master's in public policy from the University of Chicago. His fields of interest include economics of education, labor economics, and behavioral economics. So before we pass it over to William, I just want to say a few notes about the format for today. So we're going to start by having William share his presentation, and he has a few slides that he'll work through. And if any questions come up, feel free to put them in the chat or send them directly to Kaylee, especially if there are questions about data or methods. And Kaylee will be monitoring the chat to interrupt whenever necessary. And if you prefer to unmute and ask it yourself because it might be a more substantive question that you want to talk through, we'll save that for the Q&A at the end. And then following the session, we'll be having our coffee chat from 2:30 to 3 for those who want to stay after, because William so graciously agreed to host that smaller, more intimate setting where you can ask for follow-up questions or just get to know more about him and his work. And before we begin, if you would like to be added to the listserv, please feel free to drop your email address in the chat directly to me so we can get you added to that list. And I'll also put that information in the chat. So without further ado, William Delgado.
Thank you for the introduction, and thank you everyone for being here. Let me share my slides. Can everyone see my slides? Yes, okay. So this is a joint work with Lawrence Artain. So school districts, they have been using value-added models to make high-stake decisions like retention, dismissal, and compensation. And these models estimate usually the average contribution or homogeneous effect of each teacher on her students' outcomes, for example, test scores. But what if teachers' effects were actually heterogeneous? That is, if those effects vary by student characteristics. If this is one could reallocate teachers to classrooms where they would have the highest impacts. So this reallocation, this could increase the student outcomes without incurring in additional cost, which is the economic term of this is allocative efficiency. So therefore, allowing for heterogeneous effects in teacher performance measures potentially could increase test scores efficiency. So the research questions of this paper, we ask whether teacher effects are homogeneous or heterogeneous, student type specific or multivariate. I'm gonna use these three terminologies interchangeably. The second research question is, can we accurately predict a teacher's causal effects on a specific students or groups? So if you can imagine, if we can predict if a specific teacher will raise the outcomes of, for example, female students, or for example, Black students, what would assign that teacher to classroom where there are more Black students, so that in that effective. So the second and then the third research question is, would reallocating teachers to classrooms based on those predicted type-specific teacher effects can raise student achievement? So for the first research question, we develop and estimate a multivariate value-added model where teacher effects are allowed to vary by student type. We are going to use gender and race specifically because of the interest in gender and race achievement gaps. So in one model, we're going to estimate teacher effects by male and for female students. And in another model, we're going to estimate effects for Black and non-Black students. We use more than 1.7 million test scores from Chicago public schools. And what we find is that there's heterogeneity within teachers. So there's between 2 and 20% of the total variation in teacher effects. One could be explained by within teacher differences in male and female teacher effects, or in Black and non-Black teacher effects. With respect to the second research question, can we accurately predict a teacher's impacts? So for this, we're going to use a changes in teacher staffing as a quasi-experiment. So what we're going to ask is, if there's a teacher that is replaced by another teacher who is one standard deviation better quality for female students, for example, but equally effective for male students, when that teacher is replaced by another teacher, then one would should see an increase of one standard deviation in female test scores, but no change in the test scores of male students. So that's the thought experiment. What we find is that type-specific value-added estimates are actually forecast unbiased. So if I estimate value-added, the teacher effects of on female students, that's actually a good forecast for how that teacher would do with female students in the future. And with these estimates and these results, then we conduct a policy simulation where we allocate teachers to classrooms based on those differences in teacher effects. And we find some preliminary findings is that by reallocating teachers, we could increase test scores by 0.006 or 0.036 standard deviation. And that in monetary terms, that would mean that just by reallocating teachers, we could increase earnings by $1,600 or $9,800 per classroom. So this paper contributes to the literature in teacher quality in value added, since we find that type-specific value added are forecast unbiased. We can predict teacher effects on a specific students or groups. This paper also directly talks to the literature on teacher effects by student characteristics. To the best of my knowledge, this is the this is the first paper to quasi-experimentally test the existence of those multivariate teacher effects. And this paper also relates to match quality. There's a paper in match quality in education. Since we are talking about matching teachers to classrooms depending on their comparative advantage. Are there any questions so far?
Yes, we just have one question, just asking if you could explain a little bit more what this idea of comparative advantage means.
Oh, yes. So suppose that there are two teachers that are equally effective, but one teacher can raise the test scores of female students more than the other teacher. So that means that this teacher would have a comparative advantage on female students relative to teachers. So let's the value-added model, which is what school districts use to estimate the teacher effects on the student outcomes. So this is the homogeneous basic case where the outcome of a student I, whose teacher is J in year T, is equal to the outcome in previous years. So every value-added model controls for lagged outcomes. And it's also a function of student characteristics, X, and a function also of teacher effects, which is denoted by mu JT. And there's some classroom shocks and some error term individual shocks. So again, importantly, these value-added models control for lagged outcome test scores, so that the teacher effects is the value added from previous year to next year on that particular outcome. So we expand this homogeneous value-added model to incorporate multivariate effects. So the main difference is that now we allow teacher effects, mu JT, to depend on the type of a student K. So the outcome of a student I whose type is K will be a function of the type specific teacher effects, mu K, and some classroom shocks and individual shocks. So this allowing these mu's J sub K to vary by student type, that is going to create some new properties such as comparative advantage. So the intuition is, so the way we're going to estimate teacher effects is going to differ from how it is usually done because of the quasi-experiment that we employ. So the first step, this is the intuition for the base case, where every teacher has the same number of students in the classroom, where every teacher has the same classroom composition in the classroom, and they appear in the data in the same number of years in this basic case. And assuming there are two cases, the way we predict teacher effects is as follows. First, we estimate each teacher effects on each student type in every year using the normal value-added models, but we do this by a student type. So in this case, let's suppose we use gender as a student type. So we estimate for each teacher the value-added teacher effects on female students, the teacher effects on male students, and we do this for every year. And then with these estimates, we make some forecasts using prior years value added. So for example, for the first effects on female students, we're going to use estimated value added from T-1, the value added from the other type in T-1, and then all the prior value added estimates. And we use that information to make a forecast on this year's teacher effects. So that's what we're going to use in our quasi-experiment. We're going to use the forecast using prior years data.
I think we have one question from the prior slide that I missed. I'm sorry. Let's see. From this Yeah, from this slide, I think it was. So Steve is asking how do you separate MU JT and theta JT?
Yes.
Can I
So
just say, can I speak?
Yeah, go ahead.
I just, so actually, Derek Neal beat me to the typing contest. He asked exactly the same question. Just wanted to know.
yes, yes. So the assumption here is that the classroom shocks they are not correlated across years. So we estimate teacher effects.
Oh,
Oh, William, I think you're cutting out. Can you
Using
hear
previous
it?
years data.
yeah.
I'm sorry, I
Sorry,
think
I
you
think
cut out just about the last like 15 seconds.
okay, yes, sorry, I think my internet is not working well. Okay, so the assumption is that classroom shocks are independent across years. So what to estimate to make the forecast of teacher effects is the autocorrelation using the correlation of one year to another. That's the way we identify those teacher effects. Does this answer your question, Steve?
You need some more subscripts.
Uh, so no, so so okay, so for every year, for every teacher and every year we estimate their value added, and then we use the prior year data to make the forecast. So this is the autocorrelation using previous year that we are doing the forecast. So the assumption is that the classroom shocks, they have no correlation across years, and that's how we identify teacher effects.
Right, but there's a time and so there's a time and
Yes.
there's a time invariant teacher effect, and within that, there's a time specific classroom effect.
Mm-hmm.
Right, so you've got another layer of nesting. Are these random effects? Are you having some distribution on these things?
Yes, yes,
Right.
yes.
Thank you.
Okay. So that's how we identify teacher effects using prior year's data.
I just wanted to add, you've got to, if you're going to do this by random effects, you've got to lay out all of the information that someone would need to write down the likelihood function. Or this just becomes.
Yes, so I misspoke. So this is, I'm not estimating this by random effects. So
then I'm with Steve. You haven't assumed enough to actually do this. You've got to make some type of parametric assumption about either how the mu evolves over time, or the relative variance of mu and theta. Independence is not enough because you haven't said anything about what the time series properties of mu JT are.
Okay, yes, no, thanks for the comment. I have this in the appendix. Maybe I can move it to the main presentation. But the assumptions that I'm making is that all these teacher effects, and so for teacher effects specifically, I'm assuming joint stationarity. So the variance, so for each year and for each type, I normalize those teacher effects to be equal to 0. The assumption, the stationarity assumption indicates that the variance of each teacher is constant, and that the autocorrelation of one year with another year only depends on the time gap between those. And I make, so these assumptions also relate to how the two different types of teacher effects relate to each other. So we're allowing teachers effects from one type to be correlated with the other type here. With respect to the classroom shocks and individual error terms, there's also a stationarity assumption, and it is that the expected value of those shocks is equal to 0. The variance of those shocks are constant, and only the classroom shocks can be correlated between different types, but there's no correlation across years of these shocks. So those are the assumptions of this model. The intuition, we estimate this model we take into account differences in classroom sizes and different in classroom compositions, and we take those stationary assumptions into account in the estimate of teacher effects.
We also just have a question here. What is a type here that you're talking about?
Yes, so a type can be any student characteristic. In this paper, we're gonna look at gender.
I'm sorry, William, I think you're cutting out again.
Okay, I apologize. So the type here in this paper, we use gender, male and female, and also race, Black and non-Black. But a student type can be any other characteristic. So we use data, administrative data from Chicago Public Schools, from elementary and middle school from 2008 to 2016. Our main outcome is test scores for math and reading. The student characteristics that we're going to control for in the value-added model is race and ethnicity, gender, age, price launch status, special education, attendance, and suspensions. Those are the usual student characteristics that these models use. And we link students to math and reading teachers using the transcript records, and we construct some classroom rosters. And we make the usual sample selection of drop-in special education classrooms and drop-in small and large classrooms. So this is the descriptive statistics of students in classrooms. In total, we 126,000 unique students who appear in the data about 5 years in the data. The test scores are standardized by year, and the mean here is 0.11. We have 50%, half of the students are female, 10% of the students are white, 36% are Black, and 49% are Hispanic. Since we use race as one student type, and we are going to divide students by Black and non-Black. So when I refer to non-Black students, it's mainly Hispanic students in this context. Another important point from this table is that so the classroom roster size is 39 than the usual classroom size, and this is because of the way we are constructing the classroom rosters. We don't observe specific classrooms, we only observe grades. So here, this is pooling for teachers with multiple classrooms, this is pooling all those students into a single classroom roster. That's why the classroom size is bigger than usual. Two other statistics is that 94% of the classrooms has both male and female students, while 14% of the classrooms has both Black and non-Black students. So this is this is just to show you that every classroom has male and female students. This distribution is centered at 0.5. In the case of race, this is the distribution of proportion of Black students in the classroom. And as you can see here, there's a large proportion of little Black students and another important proportion of classrooms that is mostly Black students. But however, there is still some classrooms with both type of students, Black and non-Black. And despite of the differences in how gender and race behave in this context, what's interesting is that we still find similar results, that teacher effects are gender specific and race specific.
I have a question here about missing data. So Mengyuan is asking, does the all equal n mean that the data set is balanced, meaning that there's no missing data in the test scores for all of the students? How do you handle the people who did miss a test score?
Oh, in the data in the data set, only students with test scores appear. The other ones are dropped.
And then one other question that we have from Neil asks, do you consider the gender or race of the teacher? William,
No,
I'm sorry, I
it's
think
not
you're
taken
cutting
into
out. I think you cut out
Okay,
just
I'm
for the
sorry.
beginning part of that, sorry.
Yes. Okay. So that's good question. Thanks for reminding. We don't take into consideration information of the teacher. These estimates mainly use student characteristics and student outcomes. But I will show you a table where we correlate teacher characteristics with some statistics that I'll discuss later. Okay, so with this model in mind, and once we identify teacher effects, now we estimate those teacher effects by gender and by race. So this is a scatter plot of teacher value added on male students and teacher value added on female students. So again, each teacher will have two types of teacher effects of two estimates of value added. And as you can see here, these estimates are not completely on the 45-degree line, which is the red line. There's still, they're not completely correlated. They're highly correlated. The correlation between these two different types is 0.8. And yes, this by gender is more compressed than by race. So this is value added by a student race. So we estimate value added on non-Black students and estimate teacher effects on non-Black students. Again, each teacher has both value added, and this only plots the value added for teachers who actually have the two type of students in their classroom.
And we have another question here about missing data for you. So Fan Mei asks, is there selection bias since only students with test scores show up in the data set?
Well, that's a good question. It could be possible if only certain students take the test scores. But again, we are using millions of test scores. So potentially the bias would be smaller, but I cannot speak to that. So this is again the correlation between Black and non-Black value added is lower than gender, is 0.7. And if we take the difference between value added on Black students minus value added on non-Black students, this is a measure of comparative advantage. The standard deviation of that difference is 0.04. So that's about 13% of the racial achievement gap. In other words, if we replace a teacher who is one standard deviation above that measure of comparative advantage and move that teacher to another one, to a classroom where there are Black students, more Black students, we will be able, according to this model, moving that teacher will decrease the racial achievement gap by 13% in that classroom. So just by reallocating teachers across classrooms, it will be possible to raise achievement and possibly close achievement gaps. And this is a table. This is the only table where we use teacher characteristics. Here, the dependent variable is a measure of comparative advantage on female students. So this is just the difference. Again, for each teacher, we take the difference of female value added minus their estimated value added on male students. And the difference will tell us if that teacher has a comparative advantage on female students. We do that in the second column, the same for race, take the difference between.
William, I think you cut out just for about 10 seconds.
Okay. So we construct two measures of comparative advantage, female comparative advantage and Black comparative advantage, and then regress those outcomes on teacher characteristics. And what we find is that female teachers, this is the only table where we use teacher characteristics, female teachers tend to have a higher comparative advantage on female students. That's this 0.07 coefficient. And for race comparative advantage, we observe that it is male teachers who tend to increase Black students' test scores. We do not observe that Black students, Black teachers have a higher comparative advantage on Black students.
We have a question here. It's another selection question, which asks, wouldn't you expect teachers to sort into schools with students who are predominantly Black or non-Black, or unobserved school/neighborhood characteristics correlated with race and ethnicity? How should we think about selection when thinking about the teacher value added scores of Black and non-Black students, especially when you are thinking about allocative efficiency? And that's a question from Neil.
Yeah, that's a good question. That's the following slides where we're going to talk about the quasi-experiment. The idea of the quasi-experiment is to take into account those selection. So let me explain the quasi-experiment and see if this will answer your question. So the idea of the quasi-experiment is as follows. Suppose this is a school that has two grades, 6th and 7th grade. And in T-1, so the circles represent students and the other figure is the teacher. So in T-2, we observe one cohort and these students are in 6th grade. Each color represents a student type. So let's suppose that the white color is female and blue color is male. In year T-1, the cohort 1 students move on to 7th grade, and now they have this new teacher, which is the triangle teacher. This teacher has in this world of multivariate effects, this teacher has two types of effects that we're gonna call mu. So there's one type of effect on female students, the white circle students, and there's another type of effects on male students or the blue circle students, okay? In T-1 also, we observe another cohort of students that are entering 6th grade. But we're just going to focus on 7th grade. In the following year, in year T, the second cohort of a student moved to 7th grade, but here is the experiment. The triangle teacher is replaced by a square teacher in year T. And this new teacher, then will have two different type of effects. One is for female students, the white circle students, and another effect on the blue circle students, male students, okay? So the experiment, so this quasi experiment produces some hypotheses that we're going to test. One, so why is the outcome of the student? So one, if teacher effects are student type specific, one should observe that the changes in student outcomes. So let's focus on the first equation, the changes of the outcomes of the female students, the white circle students, in year T minus year T.
Sorry, William, I think you just started to cut out.
Yeah, everyone is frozen. Okay, again, I apologize. So the change in outcomes of the white circle students should be equal to the change in the student, in teacher effects on those students. Similarly, the change in outcomes on the dark circle students should be equal to the change in the specific teacher effects on those students. Moreover, if these changes in type specific teacher effects are different, then this produces two additional predictions. That is that the changes in the outcome of white circle students will be different than the change in teacher effects on the other gender or on the other student type. And similarly for the other type of students, the changes in black circle students should be different from the changes in teacher effects on the other student types. So the empirical model is as follows. So the outcome here is going to be the average at the school grade level. So start with a student test scores. And then we take the average of a student test scores across type K students in a school S and grade G. So we only take the average of white circle students. And then we take the first difference. We take the difference between year T and T minus 1. So in year T is when the teacher was replaced, minus the test scores of the students in the previous cohort for the same grade. That's our dependent variable, the changes in the student outcomes. Our main explanatory variable is the same, but using value specific type specific value added. So using our forecast of teacher effects, we take the average across all teachers in the same school and grade, and then take the difference between year T and T minus 1. Our explanatory variable is the same, but using the value added of the other student type, okay? So here, the identifying assumption is that the changes in teacher quality are independent of changes in unobserved student quality, conditional on changes in teacher quality in the other student type. So coming back to the question of sorting between students and teachers, according this identifying assumption entails that when the teacher moves from one school to another, that will be exogenous of any unobserved student quality. So the idea here is that we exploit those changes from one grade to another or from one school to another to overcome those cases of student sorting. And this is the result of the model. So in this table, we divide the sample into female students, the first 3 columns, and the male students, the other 3 columns. So for female, one would expect that the value added on the female value added explains changes in female student outcomes, but not the value added on male students. So the first row is the changes in female value added, the match gender, and the other row is changes in the other type value added. So when we control for each individually, we see that each value added predicts almost, so the coefficient, the idea is that the coefficient is equal to 1. So what we observe is that changes in female value added actually explains the changes in outcomes on female students. We also observe that just by using the other male value added also explain changes in female outcomes. And this is because these 2 types, female and male value added, are highly correlated. But when we control for both types of value added, what we observe is that only the matched gender, the female value added, explains the outcome of female students, but not the changes in male value added. The other coefficient goes to 0. We do the same exercise just by restricting the sample of male students. And similarly, the match gender value added, that is the male value added, explains changes in the male student outcomes, but not the other value added. We do the same by race. So the first 3 columns focus on Black students and the other 3 columns on non-Black students. And again, here we observe that only the matched race value added, that is the Black value added in column 3, explains changes in the outcomes of Black students, but not the other race value added. Similarly, for non-Black students, we observe a coefficient of 1 for the matched race value added, but not the other. So the next table now pulls all the students. So the first 3 columns now pulls female and male students. And now the match type value added, it would be equal to the female value added for female students and male value added for male students. And again, when we aggregate all student types, only the matched type value added, the coefficient is equal to 1. Changes in value added predicts accurately changes in student outcomes. The other type value added does not predict changes of student outcomes once we control for the other variable. When we aggregate both races, Black and non-Black students, again, the match type value added predicts accurately those changes in student outcomes, but not the other value added. And then we run some robustness checks. So to make sure that this class experiment is actually working here, we're doing a placebo test for columns 1 and 4. So instead of using current changes in student test scores, here the dependent variable is the lagged student test. So teachers in year T should not reflect outcomes in T-1. And this is what we find in columns 1 and 4, that the coefficients are indistinguishable from 0. So it seems that this placebo test seems provides more reassurance of the results that we're getting. In columns 2 and 5, here we are using an instrumental variable and using teachers who exit schools. Again, we find that the coefficient, we cannot, using this instrumental variable, we cannot reject that the coefficient is equal to 1 for the match type in both cases. And in the third column and sixth column, here we are imputing some value specifically for Black and non-Black value added. There are some teachers that are only observed with one type of a student. This multivariate value added model is able to also estimate the other type, the other effects of the teacher. So what the sixth column, what it does is that for teachers who are only observed with one type of students, the other value added is equal to the one we observe. So in this case, that means that the variation that this column is using is only teachers who are observed with both type of students. And again, we find that the coefficient of matched type value added is equal to 1, but not the other type value added. I think, are there some questions? Monica?
We do have one question here, or we have two questions here. So the first question asks, for the race columns here, does the relatively weak predictive power of other types of value added hold when you restrict the samples to teachers who have actually taught these other type students? Or is that restriction already imposed in the table? And that's a question from Seth.
Okay, I think can you repeat that question, or I think I didn't get it.
Yeah, so does the relatively weak predictive power of the other type value added hold when you restrict the sample to teachers who have actually taught other type students?
Okay, yes, so that's the last column. So in the last column, if the teacher, so the other value added, so let me give you an example. So if a teacher only teaches Black students, the value added of the other type will be equal to the value added on Black students. So there's no difference between those two. And we do that, that's the column 6. So we equalize the value added that we observe with the other value added that we do not observe and make them equal. So the variation that this last column is using is only for teachers who have different value added. So for teachers who have both type of students. Does this make sense? I hope so, yeah.
Great, thanks. And then we have one other question here, which asks, what are the application implications of assigning students to teachers based on race and gender? What might be dangers or unintended consequences?
Yeah, so I'm not suggesting here that we should segregate students. This is more about allocating teachers to classrooms that are given. So the implication of this is that it is possible, there's possibility to increase achievement just by reallocating teachers to classrooms, and this would not theoretically incur in any additional cost. So imagine it's optimizing learning. If we were able to identify, this teacher would be the most effective with this type of classroom. So this exercise, we should match that teacher with this particular classroom. So that's the implication. This is not about reallocating the students to classrooms. This is about reallocating teachers to classrooms.
I have one follow-up question. I'm just curious, like, why do you think that some teachers have this comparative advantage, either, for female students or Black students? Is it a result of the teachers' gender and race identities matching with the students? Is it something about like the teaching style that other teachers would be able to adopt? Or I guess, like, what do you think is going on behind these results?
So that's a good question. There are two explanations for that. I'm not able to, well, I have some suggestive evidence, but the two explanations is one is the teacher. The teacher is treating each student differently. And that could explain why some teachers have different, teacher effects. The other reason could be the student. It could be that they perceive the teacher differently. For example, if a female student, may perceive female teachers as it could motivate that student more. So that's the model effect. Here, we are not able to distinguish between those different explanations. However, in some analyses that are not in this presentation, within surveys, sort of to investigate if students respond differently to teachers with different teacher effects. And what we find is that it seems that the students are not reporting differences in how the teachers are doing. So the survey, so there's no a strong evidence into which of the two different theories explanations are explaining these different teacher effects. And to finish, and so we have, we estimated value added for different student types. We showed that there are some heterogeneity between teachers. Some teachers are more effective with female students than others. There are some teachers that are more effective with Black students than others. We showed using our cross-experimental strategy that it is possible to predict which teacher is going to be better with which student. So this then, with these results in mind, we conducted a counterfactual analysis in which we match teachers, we reallocate teachers to classrooms depending on those different comparative advantages of the and the different classroom compositions. And so we match those. And what we find is that when we are matching based on gender value added, the gains are smaller compared to race value added model. Compared to using race value added. Preliminary findings shows that matching based on gender value added could increase test scores by 0.009 standard deviations. That in monetary terms, it's $2,400 per classroom using some estimates from another study. But matching based on race value added, it could go, potential gains could go all the way up to 0.036 standard deviation. And the explanation is that there are some teachers, well, depending on the assumptions, there are some teachers that are in predominantly Black classrooms that seems to be better with non-Black students. So moving these teachers to another classroom would have a larger impact. In the case of gender, given that the classes are already integrated, the gains in reallocating it's lower. So the conclusions is that we find evidence that teacher effects are heterogeneous, student-specific, or multivariate. The test scores are value added on a specific student subgroup is forecast unbiased. As I showed you in the if we predict that a teacher is one standard deviation better teaching female students, that prediction, we find that female students actually increase their test scores by one standard deviation. Allowing for type-specific or heterogeneous effects could potentially improve efficiency. So if school districts could improve efficiency by allowing teacher effects to vary by student type. And the findings of this paper can be generalized to other sectors that have similar production function. For example, the health sector, in which the consumers or the person's characteristic influences their behavior and also influence their output. So in those cases where these results also apply. And that's my presentation. Thank you, everyone. And I apologize for the internet connection, but I can answer more questions.
Great. Thank you so much, William. If we could just give a round of applause for William, or I guess we could use the little applause button too. So we can turn towards the Q&A now. And if people want to use the raising the hand so that you can unmute yourself and ask the question, that's great. If you prefer for me to read it, that's fine too. You can just put the question in the chat. So we can open it up now. Okay, so I got 2 questions in the chat so far. So one question asks, you said that this suggests that we should be allocating teachers to classrooms, not necessarily students to classrooms. What could this look like in practice? For example, if some teachers have a comparative advantage for female students and many classrooms are split 50-50 female and male students, what does this mean, or what does this suggest in classrooms that don't have clear compositional advantages?
Yes. So, okay. So the point here is that, so this is showing potential gains of reallocating teachers depending on their comparative advantage. As the implication of this study is that evaluating teachers should allow for those heterogeneous treatment effects so that teachers themselves could reallocate, decide where to go. In the current case, where there's only one estimated teacher effects, that would entail that if we move around teachers from one classroom to another with one single homogeneous effects, it would not be possible to increase student test scores compared to the case with heterogeneous treatment effects. In other words, when we allow for these heterogeneous treatment effects, it could be possible to increase test scores without decreasing of other students.
Great, thank you. And we have another question here in the chat, which says, you mentioned that student type could include a lot of different things. You look here at race and gender. Are there other student characteristics that you have data on or that you think might matter here when looking at heterogeneous effects? How can we think about something like socioeconomic status or students who are starting out at different academic achievement levels in terms of this idea of teacher comparative advantage?
Yes. So yes, we have information on other student characteristics. We focused on gender and race, mainly because there's have been a lot of research about the gender and racial achievement gap. There's also research on socioeconomic status, but we don't have data. We only have data on free reduced price lunch, which it could be another interesting variable to look at. But the proportion of low income students is high in CPS. So we would not, it would be too noisy to estimate on wealthier kids. So in the case of socioeconomic status, it's harder to estimate those different treatment effects. And yes, we've focused on race and gender specifically because of the research on the achievement gaps, but we could also look at other student characteristics. But the main conclusion here of this paper is not specific about gender and race. This is raising the point that teacher effects can vary by other characteristics. So it's more general. And if we allow in the teacher evaluations, if we allow those differential effects, we could increase achievement by allowing, these differential effects.
Thanks. And if anyone wants to participate, I'm happy to be reading out the questions, but it'd be lovely to hear from some other voices too, I'm sure. But the chat is fine, so I'm happy to just keep reading them. So we have a question here that's asking, are there any other key outcomes that you think this might apply for? These results are for test scores. Do you think that these teachers that have comparative advantages for test scores are also beneficial in other ways, like a more holistic picture of what's going on for students in schools?
Yes, it will be interesting to see if this also holds for other outcomes, such as student attendance or suspensions or other what in the literature has been called as non-cognitive skills or socio-emotional skills. There's evidence that teachers who improve test scores not necessarily improve those other scores. So yes, it could be possible that there are other teachers that are better in improving those other outcomes. In this paper, we don't look at those other outcomes. But again, the point of this paper is showing that teacher effects actually are heterogeneous.
I have a question. So you say one of your conclusions is that it can be to other sectors, but I'm curious in practice, like what would that look like? I wonder if you could speak a little bit about this other sector generalizability.
Yes. So for example, in the health sector, it could be possible to have a performance measure, for example, using how a doctor affects African-American patients, one single performance measure, and have another different performance measure on how that doctor affects white patients, for example, instead of comparing all doctors as if they had equal type of patients, by allowing those differences in performance measures that could increase efficiency, instead of just of comparing all doctors or all doctors across different settings.
I guess as a I was going to ask as a follow up to that though. I think one thing, and forgive me for, I think part of it is that I'm also a little unfamiliar with some of the really some of the quantitative. I'm not as familiar with the quantitative methodologies that you're using here, but it seems like there are so many different factors that go into the outcomes that are not capturing things like test measures or test scores and whatnot. So how does this process capture true value added effects, like by just who is in the room, I guess, is like what you're saying, when there's so many non-quantifiable factors that are also influencing outcomes.
Yes, good question. That's why we use the quasi experiment. The idea of the quasi experiment is that when a teacher moves to another school, all the unobserved factors would not affect the teacher effects after the teacher moves. So that's why we use that quasi experiment kind of to avoid any unobserved correlation between test scores and student quality and test scores. So the quasi experiment exploits when a teacher moves to a different school or to a different grade, and one would expect those unobserved determinants of student quality does not follow the teacher when the teacher moves from one school to another. In other words, the move of one teacher to another school is assumed to be exogenous of all those unobserved determinants. That's why we use the quasi experiment.
Hey, William, I want to jump in with a question here. So your overall framing and point about thinking about this as a proof of concept that there are probably different dimensions of teacher skill that then produces comparative advantage, where in theory you could have this resorting exercise, and we're not at the Pareto frontier yet, but throughout the entire presentation, I kept on trying to think about how I should wrap my mind around precision and measurement error in this context, especially, I mean, it comes up certainly when you're thinking about the differences that you're observing between the gender value add and the race value add, because like we know the distribution of students who are like in those classrooms underlying to construct those measures, you're going to get a lot more precise measures for the gender premium rather than the race premium. And so have you guys done any exercises when you showed us that initial scatter plot with the correlation and then said, oh, like this would account for, I think it was like 13% of the gender gap. Is that assuming that you have perfect measurement, or is that shrinking down what you have, because everything's going to blow up when you do that subtraction? And then I'll let you talk after this, but and then in your final exercise, when you're doing the reallocation, are those sort of like back of the envelope calculations that you're getting out of this, assuming that the policymaker who is making the reallocation choices can observe these true premiums, or is it based off of the actual data that would be, like if you went to CPS today and they said, oh, this study is amazing, we should be reallocating our teachers, how much of your estimated benefit would they be able to get? Do you need like 5 years of data in order to get stable estimates here? Okay, I'll stop.
Okay, no, good questions. So the first one about measurement error, in the estimates, all takes into account the measurement error and takes into account the number of students used to evaluate those specific teacher effects. And the estimates are shrunk, and we take that into consideration. For the, when I showed you the difference between the comparative advantage of female students or male students, those are using the predicted, the estimated effects. So we, in that case, we are assuming that the prediction is an accurate measure of the teacher effects. The results here, so one limitation of this study is that we're not making claims on specific teachers. This is claims on the overall population distribution of value added. Estimating, predicting a particular teacher is more challenging because each teacher has a lower number of students. So that's one limitation of this study. But we do find overall in the population, there is variation in teacher effects, and that those overall forecasts are unbiased. In the counterfactual analysis, we use the estimates and not the real effects. So in this exercise, we are assuming that the predictions are actually accurate for each teacher. Did I answer all your questions?
Yes, you did. Thank you.
Great, thanks. We have a few more questions here in the chat. And if anyone else wants to jump in, just feel free to jump in or raise your hand. EOS in the chat is asking, have you thought about mapping the heterogeneity and the homogeneity of teachers' value added by different schools? Could it be that some schools have teachers with more similar value added, while other schools have teachers with dissimilar value added? If this were possible, how could we test this empirically?
That's a good suggestion. No, we haven't done it, but we could look at that in the future. Yeah, that's my answer. Mm-hmm.
Great. And then we have another question which says, it seems like in one of your last slides, you included suspension as a control variable in your models. How did you include it and why? Since you also mentioned that that could be another dimension of teacher value added outcomes, does that affect the analytic results? And that's from Amy.
Yeah, thanks for the question. So yes, we control for suspensions, absences, attendance, and other student characteristics. We do that to control sorting. So it could be possible that some classrooms have more troubled kids than others. So by controlling for suspensions or attendance, we're controlling for those sorting between the students to teachers. And controlling for that does not affect the results. And as a future exercise, we could look at how the other student outcomes, such as behavior, attendance. But again, controlling for suspensions and absences, that doesn't affect the results. On the other hand, that makes it stronger because we're controlling for any observable sorting of students to classrooms.
Great, and I think we have time for one more question. This question says, you've talked a lot about the missing data already, but one additional question I have is whether you have the characteristics that you are missing data on the test scores. Are you able to say what their racial and gender identities are, and are there differences in who's missing test scores?
That's again a good question. And no, we haven't done that, but we could do that and see if there are any differences between the test takers and non-test takers. Mm-hmm.
Great. Well, thank you so much. I think we're nearing the end of our time here, but if we could all just give William one last round of applause. Thank you so much for joining us today for this great talk. And for those of you who have any more questions for William, we are going to have a coffee chat following this at 2:30. So it'll be a smaller group meeting where you can continue to discuss this paper or any other questions that you might have. And I also just wanted to invite everyone to join us again next week. We will be having a talk that's a joint talk with the Center for the Economics of Human Development, and Steve Raudenbush will be giving a talk titled Longitudinal Adaptive Assessment and Instruction Increases Numerical Skills of Preschool Children. And that talk will be at a slightly different time. It will start at 1:30 p.m. and it will go till 3 p.m. So thank you everyone for joining us. I put the link to the coffee chat in the chat. If anybody wants to join, please do. And we will see you all next week.